Thanks everybody for showing up. This is SolidWorks Magic Tricks. Hello everybody in GVC land. We do have a Dory, so if you'd like to type in questions as I'm going through here, fire away. And of course, everyone who's attending live, just fire away with questions. This is going to be on some basic type of stuff that you're doing in SolidWorks. It's just to make the basic stuff faster for you so that you get more out of your picks and clicks in SolidWorks. So a lot of it's going to be stuff with the keyboard, stuff with the mouse. I'm not going to make a whole presentation for 2 hours on all the keyboard shortcuts, but some of the more popular ones. If you press R, that brings up your recent files. So if you've been working on a project, you close out next morning, you come in, you hit R, you'll see everything you were working on the last 10 files. And you can just click on it to open them from there. Now, a lot of these tricks are going to be keyboards. Like if I hold my control key down, I press the numbers 1 through 6. If you look down the lower left of my screen, you can see that it's actually changing the orientation. So it's all 6 sides of the cube, 1 through 6. 7 is an isometric. If you pick a face and control 8, or you're in a sketch, it'll go normal to that, or looking down perpendicular. Control 8 again flips at 180. There's also the wheel mouse. Couldn't get along without the wheel mouse. Left click, of course, is your top 10. You'll be seeing me use a lot of this as part of the magic trick. Right click brings up not only the popular ones, but pretty much everything you could do with whatever you just selected on. And there's even more. If you ever see a double arrow, it'll show you the entire list of things you could do. But the middle mouse button is really the one where I get my graphic navigation. I'm rotating this around right now by holding in the middle mouse button like it is a button. So it is a roller mouse, but if you click it like it's a button, it'll work. Also, it'll zoom into things. Roll towards you to zoom in, roll away from you to zoom out. If you notice that you're zooming towards nothing, you have to be pointed at something. When you do the roller mouse, it's going to roll into whatever you're pointing at. So if you're pointing at nothing, that's what it's going to zoom up to. If you ever get to the point where you've lost it, you can either press the F key on your keyboard or double click that middle mouse button. Does a zoom to fit. So I usually just do the double click with the middle mouse button, and with the zoom and the pan and all this other stuff, I can get oriented pretty quickly just using the mouse. There are combinations of keyboards that you can use with that middle mouse. So just the pressing it in and moving it around rotates. If I hold the shift key, it's a zoom to center. So it's going to the center of the screen, as opposed to when I'm zooming towards the mouse, it's going to what I'm pointing at. This is going towards the center of your screen. Shift key with the middle mouse is a pan, and the Alt key with the middle mouse is a flat spin. So with those keyboard combinations and that middle mouse button, you can move this thing around pretty wildly. I'm trying to get away from the control 1 through 6 type of thing for the sides of the cube, because I use something else now. If I hold my middle mouse button and I'm rotating this, you'll see down in the lower left-hand corner of my graphics area, there's this triad telling me which way is up. Well, if you click on one of the arrows of that triad, it takes your screen to looking straight down that axis. If you click it again, it flips 180 degrees. All right, what happens if I were to add some keyboard shortcuts with that triad? So just clicking it regular is going towards the axis, so that's a translation type of thing. But if I hold the shift key and I click on this, it'll rotate 90 degrees around that axis. If I hold the Alt key down while I do that, it'll rotate 15 degrees each click. And that's the same as your keyboard arrows. Every time you click one of those, it moves 15 degrees. If you hold the shift key while you hit those arrows, you get that same trick with the 90 degrees, spinning it from. So you're looking at the top, now you're looking at the side. So, okay, that's just a little bit on orientation. Any questions there? Yes, sir. How do I feel about it? This cube, I am going to go into the cube. I usually just hit the space bar because the space bar gives you the cube, but it gives you a lot more than just the cube, where this is just going to give us the cube where we can go to either looking straight down on the 6 sides, or you saw you can pick the corners of the edges. If you like using that cube, it certainly is handy.
Another thing I think I've noticed, and I thought maybe you could cause clarity, when you're in assembly and you're rotating around an assembly, like a really long assembly, right? By default, is it going to rotate around where your pointer is, or is it going to rotate around the origin?
Okay, his question is, when you have an assembly and you're rotating it, where does it pick to rotate it? Is it around your mouse? Is it around the origin? It's actually around the center mass.
Okay, and then I think I've noticed that you click on a part and then you rotate around that part.
Yes, and that happens where if you're using the middle mouse button, if I click on this face, I'm rotating around that face. I'm holding that face flat. I'm going to put some more features on here, and you can see that I can grab axes and things like that and move it around those. But yes, definitely you can use that to pick where you rotate around rather than just rotating around the centroid. Okay, so I've gotten all discombobulated. Pretty easy to get normal 2. If I just click on this face, normal 2 comes up. Click on the face again. I can do something with sketches. There's 2 choices. The sketch with a pencil, that would get me into editing the sketch of this revolve. This one gets me right into my sketch tool. Okay, so I'm in a sketch. I'm going to now use something called mouse gestures. So this is another trick with your mouse. If you hold down the right mouse button and move the mouse a little, you'll see this clock come up. Sometimes you'll do it by accident and wonder, why is this stuff popping up in my face? That's what this class is all about. All that stuff that pops up in front of your face, it's actually really useful if you embrace it. So if I go like this, I'm in a circle tool. So just to drag to the right is a circle, drag to the left is a line, up is dimensions, down is square. Yes, sir.
I noticed if you go in the sketch tool, I have mine set up so that it's divided into 8 sections.
Yes.
And then that's all the view. You just drag to one corner and you get the view.
Right, and I'm going to go through that as well, how to customize it. Once I've shown you a little bit on how to use it, once I've convinced you, it's great, because it sounds like you use it already. But all right, so I'll draw this circle. Here, again, more hotkeys. An Alt-C turns anything you have selected in a sketch to construction. So if you draw a line, you hit Alt-C right away, it turns to construction. You don't have to go over and do that in the property manager. Mouse gestures to the left brings me into the line tool. How do you construct lines? It really depends on when you were taught how to use SolidWorks. A common way people do now is this click, click, click method. Every time they click, they'll get a new point until they double click to get out of the line tool. So to draw a single line, you have to click, click, and then double click. Sometimes you don't double click correctly. You get that kind of stuff going on, which is why I don't use that method. When I'm in the line tool, if you click and drag, when you release it, you're finished drawing that line. You're still in the line tool. You can draw another one just by clicking and dragging, but you'll see to draw a single line, it's 2 clicks instead of 4. And I never have that little tail hanging off the end of it. So it's just a better way to construct lines. As we're talking about how to select stuff in sketches, if you do a box select from the left to the right, you'll see that the box is blue. When that's happening, only things that were entirely in the blue are selected. If you go from right to left, oops, I'm holding my right mouse button. So on my left, here we go, right to left, you'll see it turns green. Green means anything that touches that box will be selected. Hit the delete key and away it goes. Okay, so let's get back into lines. I'll go this way with my mouse gestures, start drawing some lines. Do that drag and drop option. Select all these. There's that pop-up again. So anytime you select things, it's context sensitive. So because I picked 2 lines, I've got choices like perpendicular, parallel, equal distance. If I'd only picked 1 line, I would have just had horizontal or vertical for a choice. So it is context sensitive. The top ones are typically sketch relations, where these are other things I can do. Like I can change this to construction geometry using that key right there, which is a favorite of mine. If I mouse gesture straight up, I'll get into the dimension tool. Now, when you're using this dimension tool, here's your modify box. You've got these spin increments. If you don't like the spin increments, you can reset them here. Or you've got a radio dial right here where you can sort of dial in the size you want. You can also, of course, just type in whatever you want. You can type in mathematical equations. If I want to know 100 divided by 2 and I don't want to do that math, it'll solve it for me. Selecting two lines will get me an angle if they're not perpendicular or they're not parallel. And again, I can do like 360 divided by 12. Not have to do math in my head anymore. I just type it in there. You don't need a calculator. Modify box will do it. You can even put parentheses around things, write whole strings. You can use pi, tangent, cosine, whatever you want. Have it figure out a formula for you. And it'll solve it and give you that dimension. While I'm working with dimensions in a sketch, if I go to my system options, there's a choice that I can enable putting in dimensions as I'm drawing. Some people like to do this, especially people that have used NX in the past. It's something that NX does when you're working in it. Where if I've got that turned on and I draw a circle, you see what it's doing there? I can type in a number here, hit enter, and the number takes it. So you can put in dimensions as you're going. Just like the modify box, you can type in mathematical equations. If I'd stop moving my mouse. All right, let me try that again. Put my dimension on there. When you type in a number, this is currently in millimeters. You can type in FT, MM, M, YD, all sorts of things like that for different units that you're going to use, and it'll automatically convert those for you. So I said I needed a 1/4 of an inch. It converted to me since I am in a metric template. If you do want to change your template, you should watch over here because that one's got something blocking it. Over in the very lower right-hand corner, there's this MMGS. That stands for millimeters, grams, and seconds. That's the units I'm using currently. Not only does it tell me that, but I can click here and switch those. Now I'm in inches. It does get you out of the sketch. If I double click on a sketch, I get right back into it, or at least I can see it. And you can see that it's converted all of those for me. I do want this in metric. And I'm also going to cover something else called Instant 3D. When Instant 3D is turned on, if I double click a sketch in the graphics area, it not only brings up that sketch, but it'll also take you into editing the sketch. There we go. Okay. I'm going to exit out of the sketch again and press the S key. Has anybody ever used the S key before? It's a shortcut toolbar. And again, it's context sensitive. It's got different shortcuts for sketches, different shortcuts for assemblies, drawings, parts, things like that. But you can see I can get right into a feature from there without having to go to toolbars. Most of this new interface, this magic stuff that I'm showing you, is trying to keep your eyes on the prize. You're trying to look for everything getting to you on the screen, either through mouse gestures or shortcuts or something like that, instead of you having to go over to the left to the property manager or up along the top to the command manager. All right, when you are in a sketch-based feature and the property manager's up, it's asking you for an end condition at this point. How deep you want it. If you right click while you're inside of a cut or an extrude, the end conditions will pop up for you. Like I can say up to next right from there. Hit my green check mark. Let me open another sketch here. This time I'm going to go downward with my mouse gestures and get into the rectangle tool. There's several different ways of drawing rectangles. I can draw parallelograms, or I'm going to draw this thing called a center point rectangle. It's constructed just like a circle where you pick the centroid of it and then you drag out one of the diagonals to determine the size of the rectangle. You can also have it add connection lines. You can either have it put an X in the middle of it with construction lines or a cross in the middle of it. I've got it set to midpoints so it'll look like that cross. And you can see, again, I can type in those values. With that option that I set. Not my favorite option. Not all the magic tricks I'm showing you are ones that I use personally, but just to let you know what's out there. So I'm going to do some cleanup on this sketch. I want this thing to be 5. These two to be equal. Now, you would think it would be fully defined at this point. You hit Control-8 to get viewing normal too, because I hit that top quadrant when I drew the midpoint of it. It doesn't always stick on that. The trick I like to do is if you draw a line, a vertical line from here to there, that fully defines it. How about Alt-C, make it a construction line while I'm at it. So now it's fully defined. I'll get out of the sketch. When you have a sketch that's unused and you've got that instant 3D turned on, if you select an entity in that sketch, this little arrow will pop up. And you see that if I click and drag on that arrow, I can add material. If I release it, I have the choice to change that to a cut. That actually has to do with, let me do an undo here, where I select. If I select it here and I grab that little arrow, it'll add material this way, but it'll subtract material that way. If there's material in that direction, it'll default to a cut. And you'll see that as I'm dragging this, I get this scale pop up. If you've ever noticed that, take a look at the numbers here. When I'm dragging them here, they're just willy-nilly, any number that I'm at. But if I hold my cursor over the scale itself, it'll snap to that scale. So it'll give me an exact number instead of just dragging it however far. If the scale is too fine, zoom out. If it's too coarse, zoom in. The scale will actually change with how much you're zoomed in. But the real thing that I like about Instant 3D is the fact that you can change existing geometry very quickly. Typically, without that turned on, you need to double-click a feature and then double-click the dimension to change the size. With the Instant 3D on, if I single-click the feature, all the dimensions pop up. If you see these little blue dots here, I can click and drag those. And again, they have the same rule. If I use the scale here, I'll get exact numbers. And that works here as well. So any dimension, if you click on that little blue dot, you can click and drag it and change the dimension in real time, see how that change is going to look on your part. Any questions so far? I know I'm going through a lot of stuff very quickly. There's a lot more to come too. It's probably one of those ones that you may have to watch again to see all the stuff that I'm doing. But any questions up to this point? Okay.
Do you have a table of key functions and what is the first two so that they can use it?
For the keyboard, excuse me, some of the question was, is there a key or a legend to what the keyboard shortcuts are?
What are you talking now? You and the most people.
No, I don't. But I do post a video after this. But if you do want to see what type of keyboard shortcuts there are, if you go to the customize here, switch it to keyboard, you can have it list just the keyboard with shortcuts and print the list. That'll show you all the default keyboard shortcuts. Like I said, if I did that as an entire class, that could be an entire class, but it's pretty dry. So you can take a look at them yourself, and I'll show you how to modify that soon. Also, you can modify the shortcut toolbar. So when I press my S key, it brings up that shortcut toolbar. I wish it had more stuff on there. If I right click here and choose customize, it'll bring me into that customize program and it'll allow me to set up the shortcut toolbar for parts, assemblies, drawings, or sketches. If you want just a single feature, what you need to do is find the toolbar it's on. It doesn't matter. This looks like all features here, but I can mix and match. I can drag a sketch tool on here if I want to have that on my shortcut toolbar. You can also bring out entire toolbars. That's what these are right now. If you see, they all have these little arrows on the right-hand side showing that there's a pull down. If I switch this to flyout toolbars, this will give you the entire toolbar. So if I want to be able to access, let's say, patterns and surfaces, I can bring those whole toolbars there. If I don't really like the order that they're in, you can drag around the order that these are in to change which one comes where. If you want them in a particular order, you just drag them to where you want them. Also, the orientation, if you want it wider or fatter, you play around with that, and that's what it's going to look like every time you hit the S key. The S key always pops up wherever your mouse pointer is. Again, you can mix and match, like if I wanted to be able to do features while I'm in a sketch. If I want to just make a sketch into a cut or an extrusion, I can put those on my shortcut toolbar as well. Okay, so now I press S, I can get right into the patterns here. I'll make a pattern of this hole. When you are using patterns, this isn't really a magic trick as much as a best practice. It's a really good idea to use axes if you have them rather than a face or an edge. I can use a circular edge. I can use a conical or cylindrical face to set up the axis of rotation, but those faces can get cut away. They can disappear. They can change, where if you've got an axis, and luckily we've got axes in our templates here at X. If you aren't using the one with axes in it, please do. It's nice just to have an XYZ there handy for you, and they're matched up to this XYZ here. Okay, I'm going to select this face, hit my S key, and I'm going to say that I want to do a cut. If you just pick the cut tool, it'll ask you to pick a sketch or a face. If you pick a face, it'll do this trick as well. I pre-selected the face, but if you go into cut first, what it'll do is it'll start you in a sketch on that face. So when you exit the sketch, it'll turn it into a cut. Draw a circle here. I've been using the control key for navigating around. The control key is really powerful. Also for selection. If you hold the control key, you can multiply select things. Control key will also make copies for you. If I hold my control key down and I click and drag a circle, I get another circle. It has to do with when you release the control key though. If I click and drag the control key here, I release the control key before I release my mouse. It's just a move. So with the control key held down, we'll make copies. If you release that control key, it'll move it. Yes, sir.
Does it keep the existing relations that are on that one sketch that's in? Does it copy that?
No, it won't bring it. Just brings the entity across. The question was, will it bring the relations across with it? No, it just copies the entity. I'm going to copy the face of this. So I pick the face, hit my S key. I've got convert entities, which is an offset of 0. So here I've copied this circular edge. Just to talk a little bit about putting on relations. I'm just doing a box select to get both of these, putting them tangent to the wall like that. So if I pick these, I can make them tangent with that pop-up. If you move your cursor away, you go, oh no, I wanted that pop-up still. If you hit the control key, brings that back up. So sometimes when you move your mouse away and your shortcut toolbar disappears before you got to pick your shortcut, just hit the control key and it'll pop back up. I want to make these equal as well. Okay, so I'll pick these guys. You can also, in 2016, it'll just stay up. You can keep adding relations, so I can make them equal and tangent right in the same shot. Control key to multiply select these center points. Make these horizontal, line them up. Okay. Get into my mouse gestures here. Put in a dimension. When you pick an arc, you get a radius. When you pick a circle, you get a diameter. If you have that dimension selected and go to leaders, you can change that right here. And it'll do the math for you. It's either going to be a radius, a diameter, or one of these linear types. But if it got it backwards, you're wondering why did it pick radius instead of diameter? That's why. It's a full circle always gets a diameter. An arc gets a radius. But you can change that using those leaders. Okay. I would like to do trim entities, but I don't have that on my mouse gesture wheel. Let's go to that customize under options here again and take a look at mouse gestures. If I turn these to 8 gestures, now when I do it, I get a whole lot more choices. That's usually how I have mine because it's got some nice ones. Fillet, exit sketch, convert, and trim right on there. It's a little hard to see what I'm doing on this screen. Let me change the appearance here. Okay. Everybody here has used power trim. I'm hoping that you're familiar with. You just click and drag and it starts trimming stuff away. It's a really nice tool because it allows you to get rid of things quickly, but sometimes you can get rid of too much stuff too quickly because it's so useful. Take a look at that red dot as you're trimming. If you cross back over that red dot, you can bring it back. So show you that again. Trim here. There we go. Brings it all back. And you can continue trimming. The trim tool also works as an extension tool. I don't know if you knew that either, but if you're in the trim tool and you click and drag something and you drag it past, you can make it just longer or shorter. It will snap automatically, like when it hits another arc or a line as you're doing extend. So it truly is a trim and extend tool. All right, so when I say okay and I exit out of this sketch, right away, I'm inside of the cut tool. If you double click on a surface while you're in a cut or an extrude, it automatically does an up to surface for you. And it'll terminate at that surface. So that's a useful one if you're like, I know I want it to this face. Do I use an up to next or a through? Just double click the face. It goes right to that one, then you're done. Now, when I am in part and I go to this mouse gestures, you'll see that, as this gentleman was saying earlier, the mouse gestures for part and for assembly are just view orientations. And what really drives me nuts is this one is not isometric, it's trimetric. So if you set up an exploded view in trimetric, because you did your mouse gesture and then you go into your drawing and say, give me exploded isometric, it's not going to look the same because it's at a different angle. So I'm going to fix that. I'm also going to show you a really, really cool trick. Honest, this will be worth the price of admission. Okay, so for mouse gestures, you'll see that I can have it still show me just the ones with mouse gestures. So you can see the sides of the compass, what they do for parts, assemblies, drawings, sketches. And all of these for parts and assembly are all views. I can change the commands I want. Like in assemblies and parts, I would much rather see it from the left-hand side. I'd much rather take a measurement of it. So you can put any commands here on your mouse gestures. Spelling does count. There we go, mouse properties, mass properties. Okay, and I like to make sure that I write over that trimetric, because that one drives me crazy. And normal to is one that people use all the time. So why not use that instead of looking at the thing from the right? I can put normal to on my toolbar, or on my mouse gestures rather. But here's the one, like I said, worth the price of admission. The first time somebody showed me this, I tried it. I had never used, I wasn't a big fan of the shortcut toolbar, even though it's so cool, like I showed you. But it's just accessing it. But if you switch every one of these downward, to match that shortcut, you don't need to hit the S key. Right-click, shortcuts right there. So with the mouse gestures just straight down, all of a sudden I'm in my shortcut toolbar. I can go into the patterns. And pattern this feature all I want. Okay. Just to get into what Luke was asking me earlier, was talking about the fact that if you're using the middle mouse click, you can rotate about stuff. This is a much better part here to show that off, because you can see I can rotate about a line. If I pick a face by double clicking with the middle mouse button, you can have a rotate about a cylindrical face. There we go. Or do a flat spin around a flat face. So that's double clicking with the middle mouse button on a surface. We'll change it to that's what you're going to rotate around. Okay, and also one other thing that Luke brought up was the control space brings up this cube. I usually just hit the space bar was my reply to him, because you get the cube, but you also get this choice up here. This allows you to get the sides of the cube or any isometric, trimetric view using this pull down, normal to. There's some views that are automatically built into this X template that I'm using. You can also make your own. If I want to look at this thing from a particular view, whenever you hit that space bar or control space, the cube that you get is oriented to that direction that you're looking in. So if I was looking at the front, it would have oriented it at a different point of the cube. So it's starting from where you're looking currently. If that's a favorite of mine, when I hit the space bar, there's this choice that I can create a named view. Now I can obviously hit the space bar and recall that view if I want to. I can also use that view on a drawing later on. If I want to make a drawing view, I can use that as the orientation for that drawing view. When I click on it, this red X, of course, will remove it. But what this save does for me is it saves it to SolidWorks. So the next part that I'm in, when I hit my space key, I'll have the ability to add that as or see that view. And that'll just be on my computer. It's not going to follow the part around, but you can customize your space bar to have named views that you might want as well. Yeah, it does. The exact same way. I'm sorry, I forget that there's lots of people watching. His question was if that was true in assemblies, and it is. The spacebar works same way in assemblies as well. One last thing before I get out of here, I wanted to talk a little bit about putting in dimensions again. So when I was typing in equations like 100 divided by 2, it was just solving it and then it was done with it. But if you want to have an equation that's permanent, you just hit the equal sign first. And then if you type in equals 100 divided by 2, every time you bring up that dimension, that's what it's going to show you. It's going to remember that equation. Also, this is where you can start writing equations to other pieces of the part. Like if I want it to always be come on. There we go. There we go. You just double click on the dimension. You type in divided by 2 or times 2, whichever one you want. Now when this thing changes size, when I rebuild the part, the other one's going to change size too. Can edit that dimension. Of course, when you bring it up, every time you'll see this sigma in front of it. What that means is it's being driven by something. Whenever you see a sigma in front of a dimension, it means that there's another dimension driving it. If you double, there we go, don't touch that. If you double click on the dimension, you can edit that, but you're not going to be able to put in a whole number unless you, when you do double click on it, if you turn off this sigma, it just shows you the value. When you turn it on, it shows you that it's equation. If you don't want it to be equation, just type in a whole number there. And we'll go right back to using a regular number. So that's a single equation. Again, you just do it by filling in the value. And it's just trying to drive me crazy today. That's what it is. It worked yesterday. Come on. You know, I might have better luck in this thing if I click here, edit the sketch. There. All right. Okay, another thing you can do with equations is you can also create a global variable on the fly. So if you type in equal, you double click a number, you start putting in stuff, you can have it relate to dimensions around it, as I was showing you. You can also say this equals and give it a name. And now I've got a variable called wall. See, when I bring up the dimensions for this, now this has a sigma in front of it. I can continue creating other ones. Once I start typing it in, it'll show me there's one called wall. If you pick it from that list, you don't have to type in the quotations. It'll do it itself. If you do type it in yourself, you have to put in quotation, W-A-L-L quotation. But that's how you can link values. And when you've got linked values like that, it doesn't matter which one you change. Both of them are going to change for you. And you can also get as fancy as you want here. I can say it equals wall plus 1. And so now again, you can change it at any one of these, change the value for wall, and all of them are going to change. Once you've set up a global variable like that, it'll be listed in your feature manager tree over here. So if you set up a bunch of variables, you can see them all right in that folder. If you want to see what equations are live in the part, just right click on the equation folder, manage the equations, and you can see all of the different equations that are running this thing and what their values equate to, as well as the global variables. Any questions on that one? Okay. So I put measure onto my mouse gestures here. I like it when you pick two circles, you can see the X, Y, Z. This black line is the true distance between those. It depends what you pick. If you pick surfaces, it'll start adding up the total surface area. So if you're wondering what the surface area of all these cylinders is, for some reason, you don't have to do all the math. You just have to sit here and select all of them, and now I've got them all added up. When you click somewhere off of the screen, it just clears it out, and you're free to make selections again. I use the measure tool only for really complex measurements. For simple measurements, if I pick a circle, right down here it lists where the center of that circle is and what the diameter is. If I pick an edge, that's how long that edge is. So you don't even really need to go into the measure tool for most of your measurements. If I control select and pick another edge, there's the distance between those. It does top off at a point where if you pick 3 items, it's going to have no idea what you're asking for. But if you pick 2 faces, it's going to say, oh, here's the distance between those 2 faces. It'll figure out from your selection what your measurement that your R is after. So here with the 2 lines, you see that it told me what the 2 lines total distance is, as well as the distance between them. Yeah. Any other questions? Want to move on to the next part? All right. The next thing that I'm going to open up talks a little bit about working with imported bodies. So I want to open up an IGES. Before I do, I want to tell you that IGES is a terrible file type. Don't ask people to send you IGES files. Sometimes you can't escape it. That's all they've got, so that's what they're going to send you. Problem with an IGES file is it's a surface-based file. So when you go from a solid modeler, say on IGES, it hollows it out into surfaces. When somebody opens it in SolidWorks, you got to take those surfaces, make it solid again. There's 3 points where you can have a problem there. Either the coming from the system that it was coming from or coming from SolidWorks. It's got all that work to do. There can be a problem where if they send you a step file is solid from the get-go. You skip those other intermediate steps. So that's better, but let's open an IGES file anyways. All right, unless you say don't show again, this is always going to pop up whenever you open up an imported part. Ask you if you want to open up diagnostics. If you have an IGES part, you kind of have a choice here. If you look over in your tree and you see that it's turned it into a solid, you could, let the dice roll and not run it, but it's always just easy to say yes, import it, and it'll show you if there's any bad faces that came across. Down here with this attempt to heal button, you can have it heal faces. Typically, if it's a small gap or something like that, that'll work. Sometimes when you bring in stuff, there'll be a ton of gaps and faces that were problematic. Don't just do the import diagnostic once on something like that. I've seen it maybe 2 or 3 times of attempting to heal will actually get it all the way healed because it has to heal this one before it can heal that one type of thing. If you go through like 5 or 6 times and it's not healing anymore, you can stop at that point. You're not getting anything, but do it more than once until you've got a part that doesn't have any sort of errors. You can also right click at any time and go into that tool. You don't have to have it do it when it asks you when you first open it. Change your mind later. Okay. I'm not particularly crazy with where they've chosen to put the origin in this part. So I would like to change that. This is a single solid body. So I'm going to go up to my search command here and say, I would like to move this. And anything with the word move in there is shown to me. So that's a nice magic trick right there. The upper right-hand corner of your screen is a command search. If you know the name of the command, just start typing it. It'll find it for you. If you click it here, it takes you into that command. I can move or rotate this. So if I pick this solid body, I can move it, but if I choose to also rotate it, it goes back right to its original spot. You can only move or rotate. If you want to do both, you have to do it as 2 separate instances. So I'm going to rotate this thing first. I don't really particularly care for the isometric view that they've got for me. So I'd like this thing to be standing straight up. I'll set the spot of rotation to where the current origin is now, and then I can figure out how I'd like to rotate this. You can use negative numbers in here. Sometimes SolidWorks is crazy with whether you can or can't use negative numbers. You can use negative numbers in the move body, and it'll be relative to its current position. All right, I want to do that again. You know, I'd like to actually use this all the time. You can just click and drag it from the command search right onto your toolbar. And now I've got that right at my fingertips. Another way that you can move a body is you can do it by constraints, which are similar to mates inside of an assembly. This especially works if you've got a multi-body part and you're trying to get things to fit together. But you can just run it on itself. I can say I'd like that point and that face, and it figured out you want them coincident? Yes, I do. And now I've got the origin at the bottom of that part. And I got the isometric where I'd like it to be. Yes?
When you import, does it also import all the construction features like the axis?
It depends on your settings. So, sure, I'm sorry. His question is, how much does it import when you import a body like that? It depends on what settings you do. Like for IGES, before I select anything, if I go into the options, I can pick how much geometry I want to come through. If there are curves or sketches or things like that inside of the geometry, these allow you to bring that in. You can also bring it in, I want it to stay a surface. I don't want it to make a solid. You have options like that in here as well. And it depends on what file type you bring in as far as what options you have.
Another question, when you're in the circuit, does it shows the details of why it's failing? Can you see that?
It'll just show an edge. If you click on the face, it'll highlight the edge of where there's a gap. So you can see that location. Because sometimes if it won't heal it, you can click on it, see where that edge is, and go in with surface tools and try and fix it manually as well. If you can't get the diagnostics to fix it for you. Because that's all it's doing, is it's just plugging holes for you that are in there. Does that answer your question?
Yeah.
Okay. I'm also going to export out of this thing, save as. Okay, so I told you IGES files, don't do those. Step files are great. Inside of X, we can use parasolids, which are going to be the closest to the real thing for SolidWorks. NX uses the same kernel. It's basically, it's just the geometry. There's no features behind it, but it's going to be the same geometry that was inside of SolidWorks. This is also a good way to strip out features. If you want to send somebody something and you don't want them to see how you built the part, you can save it as a parasol and all they get is that imported geometry and you can see how you built it or make changes to it. There's two parasolids. There's X or T. What's the difference? The spelling, of course, but T is for text, B is for binary. Besides that, they're pretty much the same file type. It's just how it writes it out. All right, so that's called a round trip. When you do something like that, you saved it in SolidWorks and then you shipped it out of SolidWorks. Sometimes it's a good idea to do that if you are sending somebody something, to open it back up in SolidWorks to make sure that whatever you did stuck. Now you see when I run the import diagnostics, there's no problem with it like there was with that IGES file. And I've got my origin where I want it. Now, when you are working with an imported body like this, you don't have any features or sketches or anything to control the size, but you can obviously start a sketch, drill a hole, do a chamfer, things like that, machine features into it. You can also get rid of things. I'm holding down my control key and I'm picking all the faces of this top fillet. And I'll go to my surface toolbar. Actually, I'll go to it from the shortcut toolbar. Try that again. I want to hit delete face. You can do that, where if you delete a fillet, as long as it's not blending into any other fillet, what it'll do is it'll basically extrude those flat faces up to the virtual sharp. So you can get rid of a fillet that way. You can also get rid of holes that way. If I were to pick these faces here, and do that same thing, you can get rid of things like that. There's another tool. If I right click on a face, go over here, it's called Move. Again, you can do it as a translation. So if I want this D cut to go further in or something like that, I can move it as a translation, or I can rotate it. I can't do both. For my parameters, I can choose to do an axis. I've got these axes here, but you can also, any cylindrical or conical feature will have an axis running through the middle of it. So anything, any hole you've ever drilled has always had axes in there. They're just hidden from you. They're called temporary axes. So I can use that as something to spin this around. Just like any other feature inside SolidWorks, if I click on it, one of the choices is Edit Feature. And I can go in and I can add more items. When you're doing something like a counterbore or a countersink, you have to make sure that you pick all the faces of that hole in order for this thing to work. So I can move that one. If I want to get rid of these, I can use that delete face option. If I click here, now before you start getting mad, why is this thing clicking in front of my face? It's one of those things. Let's watch what happens if I just scroll over. What it'll allow me to do is I can pick an entire feature in one shot. So it's picking the adjacent faces for me when I pick that face. All right, try this one more time. There we go. Okay, and with these things that are moved, you can do a circular pattern around it if you'd like to. You know, so if I needed, instead of just one of these, I can make a pattern. Again, if you're going to use faces like this, you need to make sure that you pick all the faces in something like a counterbore. So you can work with geometry that is inside of an imported part, just a little more difficult because you're working with the faces rather than actual sketches and extrusions and things like that. All right, but I'm actually going to get rid of all that because I want to talk about another tool. It's a SolidWorks professional tool called FeatureWorks, and it gets a lot of bad press just because people misunderstand how to use it. It's not a way to take an imported body and turn it into a completely featured parametric part. I know that it may be sold like that, but that's really not how I've seen anybody really use it. If I right-click on an imported part, FeatureWorks is a choice. It's got some options as to whether you're going to overwrite the file you're working on or create a new one. It's also got choices for where it puts in dimensions for you when you recognize sketches. And here's a nice one, whether it recognizes holes as feature wizard holes. So it can recognize a counterbore or a countersink or things like that. So when I right click and go to FeatureWorks and choose to recognize features, this is where people get into trouble. They'll just hit the green check mark and let it go on its way, and it'll try and figure out, but you're asking a computer to figure out how to model this part, and it's not very good at it. It's going to find whatever feature it can first. Very rarely does it get it, solved all the way down to nothing. But a better idea is to turn this to interactive and go through and do it yourself, where I want to check for holes. There's some nice options down here. If you say chain revolved face, that gives you the ability to just pick one face and it figures out, oh, that's a counterbore. Because it sees that it's a chain of faces that's revolved. Also, if I tell it to recognize similar, I only need to pick the one. As long as they're the same size, it'll put them together. And if I think they're in a pattern, which these seem to be a circular pattern, I can ask it to find that for me as well. And when I hit recognize over here, it found those other three counterbores for me. And I can continue doing this, whether I'm doing one hole at a time. Because I had recognized similar, it took those both out. It did give me a little bit of a warning there to tell me that there was no circular pattern found for those two. Okay, and I can also get things like fillets. If I say chain fillet faces, I just pick one and it'll try and find if that fillet goes all the way around the part. If you recognize it, it's going to turn it into a feature that you can change the dimensions on. If you say delete faces, it does just what I did manually, where you picked all those faces, deleted them, and it just gets rid of them to the virtual sharp. When I hit the green check mark after I've recognized all these, you'll see that now I have features that I can drive with sketches, or even better, I can go in here and change this counterbore to a tap, to a countersink, whatever I want to do. So rather than it just being a revolve that I have to manage, because I told it I wanted to recognize hole wizard holes, I can make it be any hole wizard size I need it to be. And I can start putting dimensions on it, things like that, get it fully defined. Control 8 is what I use to get me into normal 2 while I was in the function. And there we go. Now it's just regular holes. When I am using delete face, which I've used a few times here, if I pick both of the flat and the circle here and choose delete and patch, it'll get rid of that entire hole and close up the top faces. If I just pick the flat, it'll just get rid of that and solve to the cylinder that the hole was. One more thing with the move face, I've got all right. I'm just going to right click on it. More than one way to get to it, right? With the move face, when I've got simple holes like this, I can just pick the top and bottom face. And when I move it, there we go. When I move it, you see it brings the holes along with it. And you can put in a value here. That's only for simple holes, for circular holes. If it's still been a countersink or a counterbore, I would add pick the faces of that counterbore to move it up with the face. But there we go. I can have it move the entire thing. There we go. I forgot to get the bottom face in there. You can always edit it. Pick another face. How about I pick this face as well? Take a look at what it does. It actually extrapolates, so this thing's like a fluted shape. It figures out that flute shape and just continues it. What it's doing when it does this move face is it's just doing an extend surface for you and then capping off the surface for the value that you did. So just like when you do an extruded surface, that's one single face. You don't see a line where it used to be, where you stretched it. It just continues that face all the way up. All right, let me change the material. This thing's very dark. still pretty dark. You notice that when you right click on the materials, you get this shortcut of often used materials. You can actually manage that. You can go into favorites here and you can add different materials that you want to use. Just click on it, add to it. And then you've got that choice on your right click. Okay, I would love to have a logo on this thing as my next project for this little guy. He had to get taller, had to move that thing inside, change the counterbores. I also want to put some logos on the side here. There's a few different ways of doing it. First off, let's find a logo. Got a part here that just so happens to have a logo. SolidWorks has a lot of hotkeys, as I've been showing you. There's also hotkeys from Windows. Control S is save, Control O is open, Control W is close, Control Z is undo, Control C copies that sketch to my clipboard. Go back into this part, pick the plane I want on it, Control V pastes that sketch to that plane that I selected. You want to be careful when you are doing something like a logo. So I go into this part and I grab this, that's not the logo anymore. So don't do that. Before you do anything, you want to capture that shape. I'm going to just do a box select to grab everything and turn it into a block. Now, it moves all as a unit. Also, I can change the angle or the scale that it's at. So it does a lot of stuff for me as far as making my life easier. There's one tool that I can use called wrap. If I type in wrap, hit enter, it'll take me into the tool. It asks me to pick a plane that I want to use or a sketch that I want to use. And this will only work on cones and cylinders. So if you try and put it on a sphere or a donut shape, a toroid, or an irregular surface, it'll tell you you can't do that. So see if I click that, it says, no, that's not a cylindrical surface. If I click that one, it's fine with that. So wrap only currently works on cones and cylinders. It's supposed to work on more than that in future versions. They showed some new ones, but for today, that's all we've got. You can only go in which direction. See the little gray arrow shows you which direction you're going. And there's three choices you've got. Emboss, which will make the thing stand out. Deboss, which is engrave. You put it inwards. And scribe just breaks it up like a split face, where it doesn't actually change the height of the thing. It just breaks it up into its own face. We're going to do an emboss. I set the height here. Let me try this again. What did I do to our logo? Okay, so you're going to watch me do some troubleshooting. If I want to make sure something can be used for a feature, really the first thing I'll do is I'll just pick that sketch and try to extrude it. If it can extrude, it'll be fine, but it's doing a thin extrude, which means that when I did that click and drag, I didn't put the points back together. So no problem. What I'm going to do, still got the same thing copied and pasted to my clipboard. Looks like this one's doing a little better. Yeah. Okay. Sorry about that, but see some on-the-fly troubleshooting. Let's turn that into a block again. Try this one more time with the wrap. Now you see wrap is grayed out right now. It's kind of a finicky tool. Extrude and cut allow you to get into them when you're inside of the sketch. For whatever reason, wrap wants you to be out of the sketch. And it's even better if you actually just have it selected first, and then it'll be available. Hooray, it worked this time. So you can see these faces been extruded out from here. Okay, but what do you do if you do want it on a fluted surface or some irregular surface like this one, first thing I need to do is I'm going to copy the block. Once you've got the thing as a block, just keep using that. You don't have to make the block again. There's a couple different ways I can do this. It depends on what I want for the end geometry. I can do it as an extrusion, where I pick the entire sketch, extrude that by, instead of extruding from the middle of it, which would be bad since this thing's supposed to be an air intake and it would fill it up with metal, instead of extruding from the sketch plane, I can extrude it from a surface and start it extruding from there. Leaves the thing hollow. When I do create the geometry like that, it is different than this one in the side profile. I don't know if you can see this, how this one is normal to the face of the cylinder, and this one is normal to my sketch plane. If you don't care, then we're done. If it is a problem, we can do it one more type of way. And that's using the split line, where I can split up a face. So I pick the sketch that I want, the face I want to do it, and I can even make it go in just one direction. If I didn't pick one direction, I would have broken the face on the back side as well. But you see, I've got these surfaces now. So that's what a wrap scribe will do for you. But with these, I'd like to go into my surfacing toolbar, do an offset of 0, copies all those surface bodies of my logo. Again, going into my surface toolbar. The mouse pad's driving me crazy. Okay, sorry about that. All right, what I want to do is I want to thicken this thing. That wasn't even on that toolbar anyways. If I pick a face, it will offset it either inward or outward, or you can do both directions. The thing with both directions is if I do 0.5, it'll do 0.5 this way and 0.5 that way for a total of 1. So it actually doubles the number, which is not consistent with the other types of things in SolidWorks where it has a choice of mid-plane and things like that. But just to let you know that it will put this value on either side. If you hit your enter key, it'll get you directly into the last feature you were in. Hit enter, pick the face, hit enter again, it accepts that feature. So I can use that enter key if I need to quickly continue doing features. That enter key will always bring up whatever last feature you were in. All right, you guys have any questions for me on that example? We got anything in the dory, Ed?
No.
All right.
How would you draft?
Draft like make a drawing of it or?
No, like how to draft?
For this, I would do a, I'm sorry. He's asking me if I wanted to put draft on this. I would need to draft. For this one, I could draft it since it's coming perpendicular to the that plane. I can use that plane as a drafting tool. If I was going to do this one, since it's coming out perpendicular, I would want to do a parting line and set the pole and then actually start the draft from that line. So it would be a process, but that's how you can do it, is you need to add it in manually.
Because I just had a similar situation where I was adding a box name, a part number to a plastic part that was to be injection molded. And in the end, worth my time.
Right.
The molders are going to add draft to and then machine the molds.
And that typically is true, but you can put it on there to, give them less rework time or less finish time. But that's how I would do it. I would use the parting line and then pick the edge of that, and you have to do each edge pretty much at a time.
Can't pick a surface and draft on surface.
Not that,
The problem with drafting surface is that it drafts from the orientation of that surface. So if you pick the plane, it would drop the part in way far.
No, but you want the draft to start at the surface, and the plane defines the direction. The directional plane, or the curves that result is where the draft actually
But
starts.
you'd have to have different planes for different.
no, you wouldn't need to have different planes. You just need to use different edges.
So it would be curve-driven draft from that, in the direction of the plane.
Right. So this is my direction, but I would need to tell it, where that draft is happening.
So you can't pick a surface that would do all those things.
Well, it will not let me pick when I pick direction of plane.
Well, can you summarize the discussion going on?
I'm sorry. Yeah. And we're getting kind of off topic here. We're getting into a discussion about draft here. They're asking me, what if I wanted to draft these faces here on this logo? And I was telling them about the fact that you can pick a plane, you can pick a particular edge and just draft that face starting at that edge, like you were saying. The question is, can I use the surface as a direction of pull so my angle is actually being measured off of the surface? It only lets you select planes in here.
So in this case, then you have to do, I don't know, 10 or 12
Drafts. Yes. So it would not be terribly easy.
I think I just haven't used the party line button. I've used it a lot with the party surface.
You come from Creo or you come from SolidWorks? Creo has a way to do it. Just all of them together. That's why we're asking that.
Screw also have ways to reduce all normal edges.
Okay, guys. Let's get back to the presentation here. Do you have a question back there? All right.
We're just give it context to the reason why we're asking.
Lord, I have one question.
Yes, sir.
To cap that all off, didn't you, when you initially did the extrude, didn't you just add your draft in there?
I could have,
The surface doesn't work.
but yeah, it wouldn't be right because it's the surface it's using is curved rather than planar. So
If you pull the direction of the extrude, if you choose a plane for your direction of extrude from the
Mhm.
surface, it doesn't.
right. Okay. Wanted to show you some other places of where to get part geometry. I'm going to use a couple of websites here, 3D Content Central and McMaster Carr. 3D Content Central is one that SolidWorks posts. It's got a ton of suppliers. If I click on the suppliers here, a lot of them are people that we actually do business with. Festo, TE Connectivity. They have bunches of models out here. Boston Gear, ABB, all kinds of people that have free solid models for you. This is a great place to get it because it's coming from the supplier. It should be accurate. It's as accurate as they want to put out, right? And it's free because they want you to use their stuff. So they'll give you the models. Sometimes they'll ask you for an email address or something like that so they can ask how many you want to buy shortly after. But it is a great place. It also is a place where users put up stuff. So I want to find a carburetor. I'm just going to put in carbu because it's an international thing. There's tons of ways of spelling carburetor internationally. If you click on one of these, it'll actually take you to look at that part. You can choose which version of SolidWorks you're going to use, whether you want it zipped, whether you want an email to tell you, give it 4 stars or what have you. Hopefully, if my internet connection speeds up here, you'll be able to see a preview of it as well that you can spin around. All right, maybe I'll come back to that. See if the preview's there. I did download it already. And it came in, it's the real deal. It's the SolidWorks assembly. It's got a ton of parts to it. When you are looking at your file open, you can be more choosy with these quick filters. I love these things. You click here, that's just showing me the assemblies and the sub-assemblies. They even added this one over here. That'll just show you the top level assemblies. So I don't have to wonder which one of these things is the real deal. If I go top level, it'll open up this entire thing. Okay, so here's a little carburetor that I would like to use. Whenever you select on an item in 2016, you'll get this thing called breadcrumbs pop up in the upper left-hand corner. What that allows you to do is you can go through the hierarchy. So I pick that face. I can work on the things for that face, for the revolve, the body it came from. I can open up the part, or in this case, I can take a look at the assembly or the subassembly that it came from and just open that directly. So you don't actually have to go into the tree using those, the breadcrumbs. I don't like having to go up here either. So the way that I've started using breadcrumbs is that I wasn't using it all before because it was a new thing I had to do to go over to the left and pick stuff there. But then somebody said, if you hit the D key, it'll bring the breadcrumbs right to where your mouse is. And that makes it a little more useful where you can pick a particular item, right click on it, and you can work on whatever that was. Since I picked the part, it's going to delete the part. It is asking me, do you want to delete the entire subassembly from here or just the component? I'll say just the component because we're going to put our own branded knob on this thing. All right. Let me make this a little more manageable. I don't want this to come in as a zillion parts. I just want this to be one component in my bill. So when you have PCB boards or assemblies that you're getting from suppliers and you just want to call it out as a single unit, you can save this out as a part. It won't have any type of connection to them, or if you make changes to the assembly, part doesn't know about that. You need to refresh that part every time you make changes. But it is a nice way to sort of rein in the insanity as far as the hierarchy of the thing. Rather than having dozens of sub-assemblies underneath this thing, it's just going to be a single part.
When you say refresh that part, we actually have to go back and say as.
Yes. You have to do what I'm doing here where so the question was, what does refresh part mean? It means going through this step over again where you switch it. You say, okay, I want to save this assembly, save it as a part. It'll have 3 flavors. Exterior faces, please don't use this one. What that'll do is it'll break it up into surfaces. So every exterior surface will be its own single surface, which means you can't do extruded cuts through it. You can't really delete features, things like that, because it's just faces. It becomes very difficult to work with downstream. These 2 choices, exterior components or all components, are the better ones to use. I typically use all components, which, as the name implies, will be everything inside of the assembly gets its own body. When you're talking about just exterior components, you can think of that like a refrigerator. If you save a refrigerator, you don't get all the trays and, things inside the refrigerator. You just get the Hulk and the doors, what's on the outside. Okay, so I'm going to save this as a part. Close that out. And show you this is what an imported part looks like. So if I look at my feature manager tree, every single component that was in that thing has its own body now. So I can delete those bodies out of there if I want to, or I can make changes to them. I can do cuts and things. It is a solid. Yes, sir.
Is this aid or rebuild time?
It will help your rebuild time. It'll help your load time too. Because when you're pulling over an assembly into your RAM, if you've got it set to full weight, it's got to bring in all those subassemblies, all those components. If it's one part, it's done. The redraw and refresh, you're not going to get any sort of thing because it's got the same geometry that it's got to draw. The thing that you're going to get is when you first load it up, it's going to take a lot less time. Yes.
Exterior faces is quite a bit faster.
Yeah.
You just say it's faces.
Oh, yeah.
That's faster than setting the body. For opening.
Right, and it's a smaller file. It's just that you can't really do anything with it. You're stuck with how the geometry is. If you wanted to start, recognizing features or cutting faces, none of that works.
You do a PCB with 2,000 components.
Faces.
Go with faces. If you don't have to know.
Sure. So there were some questions back and forth. For PCB boards that have thousands of components and things like that, if you save it as faces, it will save a smaller file and much quicker with the rebuild time. But again, when you do that, if somebody's taking that PCB board and they want to take off connectors or something like that, they have to do it like a surface model. They have to be aware of that's what's going on when they do that. Now, whether you do surfaces or solids, I'm actually going to do something that's kind of strange for this, but I want to show you the scale tool. I'll do that box select from right to left. Remember, that grabs everything. And I'm going to scale this thing. I actually am sort of doing it as a placeholder. I want something like this, about half this size. It's automatically set to centroid, and that's more for using this tool when you're actually making molds and things like that, where it's shrinking the part about its center. And so it shrank each one of those parts around its own individual center, which is not at all what I wanted. If you go back into the scale, for an example like this, what you want to do is you want to use one constant point. You can either use a coordinate system set up yourself, or you can use the origin, and then it'll shrink the thing XYZ about that point. And so you'll still have all the pieces where they were in relation to one another before you scaled it. All right, some more customization. Before I get out of here, I wanted to talk about the keyboard. So I showed you earlier that you can list all the commands you want. If you want a particular command, you can type in a command and then just type in what you want. If I do Alt-V, there you go. If there's already a command that has that, it'll warn you. It'll say, hey, this one's already in use. You get a choice, cancel, panic, don't do it, or you say, okay, and that's what that key does now. You've overwritten it. So you can actually overwrite the default if you want to. So, but now if I go Alt-V, it'll tile all those vertically for me. If you have two, it's great. If you have three, you saw it was a little dodgy because they're all so thin, it's hard to see. When you get to 4, it's nice because it puts them all in a quadrant for each other. Different ways of putting parts into an assembly. You can click and drag a part, put it in the assembly. Also, when you're in the assembly, one of the shortcuts is insert part. Anything that's open will be listed here. Click it, you can see a little preview. All right, I want to talk a little bit about how to mate things up. So I rarely use the mate tool, just the hitting the paper clip. More often than not, what I'll do is I've got a part somewhat positioned how I want it to go into the assembly. If you select a flat face, hold your control key, select another flat face, it'll give you options for how to mate those up, pop up on your screen. So that's typically what I'll do. If I'm going one mate at a time, I just pick the two faces and then I mate them. So you can do that between different faces. Also, whoops, it's supposed to go this way. If I pick a face and then another face, it'll give me options, but I can override that. So it was going to coincident. Face to face is automatically coincident. Cylinder to cylinder is concentric, but you saw on that pop-up, you can switch up and pick any mate between those two faces. If you just hit the check mark, it'll pick the most obvious one, but if you override it, it'll change that for you. So cylinder to cylinder makes a concentric. You can hold the Alt key down, pick a cylinder. When it comes over another cylinder, it puts that mate on there. As you're doing this, you can use your middle mouse button as you're dragging to reposition that thing. So these are called smart mates where when you pick a cylinder and you hit another cylinder, it's concentric. If you grab an edge and drag it onto another edge like this, it'll give you something called a peg and hole. You see that when I get to the edge of this thing, I did it for a second. Hang on. I am holding the Alt key down while doing that. It should, actually, for this one, I really just need a concentric so I can do that. I'll show you in a second that if you hit edge to edge, it'll actually put in a coincident and concentric at the same time. Let me show you on another example. So another place to get parts is McMaster-Carr. Obviously, we get a lot of parts from McMaster-Carr, but they have SolidWorks files available for you. If you go in through their little thing where you pick what kind of parts you want, maybe the size that you're after, the material, once you get all the way down to the particular product, here's the data sheet for that. Right next to the data sheet, I can save this out as a SolidWorks file. Hey, I've got one here. You can also just drag and drop from there. Okay, let's take a look at, I'll do the trick with this one. So it's the Alt key, again, is the magic key for this thing, and there we go. It puts concentric and coincident in at the same time. So if I click on this part and say view mates, concentric coincident. So it's a really nice tool for putting in hardware. If you hold the control key and the Alt key at the same time, copy and put in the mates in one shot with just a click and drag. All right, let's take a look for another McMaster part.
A question on the last one.
Sure, what's up?
When that added the two mates in, did it make the flat surfaces? You said coincident?
Yeah.
It made the flat surface and the hole.
Yes, so the cylinders were concentric and the two flat surfaces of where those edges are will be coincident. It does not lock rotation. Yep, so if I click on here, it is under constraint, but here's another trick. If I go in, I click on the part, say show me those, I can right click and lock the rotation on a concentric. You can also delete or edit things from, but when you do that, it shows you just the two parts that are mated together and what mates are between them. But yeah, that's how you can fully define those guys. It's just lock the rotation. What's up? Yes, and I'm gonna do that one as well. I'm gonna do a few mating tricks here, so I will get to that question. His question was, can you do a lot of mates at once? And yes, we're gonna do that as well. Okay, let me find another part here from my McMaster library. Now, the guys at McMaster-Carr really love putting detail into their examples. That's more detail than you really need when it comes to a bolt. You'll see a lot of these in your assembly. It can be problematic downstream. If you go into a wireframe or a hidden line's visible and you start rotating the thing, it's got to draw a million helixes as the thing's rotating. Just kills your graphics. So let's find out what is taking so long to build on this part, and it'll also take advantage of what we have to redraw on this part. If you're in a part, there's always this performance evaluation. What that shows you is how long this part takes to rebuild on your computer, as well as it shows you, you know, what's the biggest culprits here. The biggest culprit here is this sweep. I can right click on here and suppress it right from the thing. And now it's not the longest thing at all anymore. The time has switched to somebody else. But that's a good idea to simplify these things. And I'll show you some other stuff later on for how you can find these things once somebody has put these landmines in your assembly, how you can go about getting to them and changing them. If this was brought in as a step file or a parasolid file, you just need to extrude a cylinder over those threads. It'd be the way to do it. But McMaster-Carr is actually a native SolidWorks file, so we can turn the features off if we want. Now, before I get out of here, I'm going to pick this edge, go to my shortcut, go to my reference geometry, and create what's called a mate reference. A mate reference is setting up the part for those smart mates ahead of time. So remember, if I pick a cylindrical face, it'll do concentric. If I pick a flat face, it'll do coincident. Pick a circular edge, you're set up for that peg and hole. So if I just pick a circular edge and don't give it any name, it's going to assume I want to find a peg and hole for this, just like it's a smart mate. But the thing is that I don't need to smart mate it at all. Here's a trick. If you go into the File Explorer over here, you can browse for files. You can also see what's open currently in SolidWorks, even what's in your RAM. Anything that's highlighted here actually has a window open. All the rest of this stuff's in my RAM. And this stuff over here, remember the hit the R button? That's the recent list. So here's that bolt I was just working on. Because it has a mate reference, if I drag this thing into an assembly from a File Explorer, it's already set up to put in a mate. It put it in upside down, of course. Let me try that again. If it comes in upside down, hit the tab key before you let go of your mouse, and it'll flip it over. But with those already put on there, it's pretty easy for me to just drag and drop, start popping nuts and bolts in. Any questions on smart mates? How I was able to do what I just did there? Okay, let me... No, McMaster-Carr unfortunately doesn't have the smart mates already preceded in their stuff. That'd be nice.
Lars, could you go over your advice on tool features using McMaster-Carr?
Sure. Let me do what I was doing here. Finish this up. I'm just clicking all those parts and dragging them and dropping them into a subassembly to change their location. So I put them in at the top level and then remembered, oh no, I don't want them. You can click and drag stuff in and out of subassemblies when you're at the top level. The question from the back was, SolidWorks has a toolbox. We have SolidWorks Professional. We all have the toolbox. Should we use it? No, we shouldn't. It's a great thing to use for small teams when you're all working off of one server and everybody's pointing to one spot. But X is gigantic. We got different people using different vaults, using different toolboxes. We would need to have a CAD administrator to do a toolbox right. So I would not use them. I would rather you use the McMaster part. It's also got a McMaster number inside it. When you open up a McMaster number, the configuration name will be the McMaster part. So there's other bonuses to using the McMaster, but I would use that instead of toolbox if you can, just because we don't have the infrastructure to manage a toolbox vault correctly. All right. So now you look at this assembly. You see it's got all these pieces in here. That's lovely. I'm going to save it and close it. Now, to make copies of a part, I showed you that you can control, drag, and drop, make a copy. That's fine with a single part. It's always going to be a single part when you're doing it at the graphics screen, where I want that subassembly. I clicked and dragged on it, and I only ended up with the cylinder. If you want a subassembly copy, what you need to do is find that subassembly and then click and drag, control drag out of the feature manager tree at the hierarchy so that you get the actual subassembly instead of the component. Smart mates will work at the assembly level as well. So if I hold my Alt key down, I can snap this right to there. Tab key reverses it. So we can get this thing in there pretty easily. Okay, get that one lined up. Now what I'd like to do next is I'd like to have some more nuts and bolts here. I have to hold in this new cylinder with one of these. Actually, I need both of those. If you group select, click and drag, you can get copies of both of the parts. If you do them individually, they just do them individually. This is getting really busy for me to see what the heck's going on here. So I'm just going to pick a few parts that I'm interested in. Select those items, right click, isolate. Now I can see what's going on. The assembly's still there. Everything's still mated in place. It's just hidden everything except for the items that I selected. So now I can get down to business. So the question earlier that I put off was, can you put on a bunch of mates at once? That's the time that you want to use the mate tool. If you're just putting on mates, onesie, twosies, the smart mates is where I go with all the time. But if I have to put in a bunch of stuff, I have to do some heavy lifting. I have to put in all four of these. I don't want to do them all individually. If you have the mate tool open, you can continue mating. There we go. You just have to hit the green check mark. So I can put in mate after mate, while still in the same tool. If you want to mate a bunch of things to the same piece, stop picking that edge. There we go. What you need to do is you need to turn on this button right here. So this is called the multiple mate mode. And what this allows me to do is I can pick a single datum that I want everything to mate up to. So I pick that face. I'm going to turn on this create multi-mate folder, show you what that's all about in a second here. Here we go. So I can make that one coincident, that one coincident, that one coincident. So you can put on, if you've got a bunch of things that need to sit on a table or be a certain distance away and be all the same distance, you can put them in like that. Is that what you were asking me earlier?
I'm looking for an easy way to plug 25 holes and 25 screws.
Yeah, I would put a mate reference on it and just did what I did where I was just dragging it from the file and just popping them in one at a time, unless they've got a pattern or something. All right, and I'll get into using them as patterns as well. But yeah, if it's like that, there's another thing I can show you as well. But what this does for me, if we look at the mate groups, because I chose to do it as a mate group, I have this. If I hadn't chosen that, it would have just put them in loose as their own mates. But because they're grouped, if I right click on them and edit, I can start adding more items that need to line up with that. Or less, but it's editable.
One of the problems that we've seen recently with like a sketch pattern drive more or less is if you ever load the part that the sketch is in as a lightweight part, because the sketch is or that.
Okay, I'm getting ready to work on another part here. Make sure I got the that I dropped in as well. Isolate just those. Actually, let's take a look. So another way that you can bring in a lot of things, if you've got like this nut, if I click on it and look at the view with mates, it's got a circular or concentric and a coincident. That's beautiful. That's what I wish this thing had all over the place. If I right click on this item, I can do a copy with mates. And what the copy with mates allows me to do is I can first pick the component. Yeah, that's the one I want. And then it shows me what mates are on it currently. It's got a concentric and a coincident. I have to just match up what I want concentric and what I want coincident, and puts it on there. If I right click on my mouse, it takes me to the next one. I just pick the faces that I would like to do it on, and it allows me to make copies of this thing as well as reuse how it's made it in there. So I don't know if this is faster than clicking and dragging out of the File Explorer, but it's another way of doing the same thing where you got a bunch of pieces and you want them all mated quickly. You can just say, okay, just like that bolt is, I want to continue using those mates.
There's also the repeat button, so if they're all the same face, you can actually do it.
Right. I'm sorry.
Once instead of twice.
Right. And I should have done that for my coincident because they all were using the same coincident. But if you click on this repeat, the next one that you use will use that as well. Okay, so I got nuts and bolts. Let's take a look at another way of finding out information about your assembly. On the Evaluate tab, there's several different things that you can get as far as what's in your assembly. You can hit the performance evaluation. It'll tell you how many parts are in there, the depth of subassemblies, resolve components, things like that, how long it's going to take for this thing to load up, basically. Some other information that I can get can be gleaned out of this thing called assembly visualization. And it's pretty open as to what I can get. I can set it for mass. If I do that, I can have it highlight in color what's the heaviest. You can even change where the color starts or ends. So if anything under 100 for me will be blue, everything else will be red or purple. So you can do that sort of thing, see what's the biggest part, what's the heaviest part, for those types of things. When you've got that, you can click on here and save that as a display state so that if you get out of the assembly visualization, if you want to, you can go back into your display state and it's saved what that looked like. More importantly, this assembly visualization can find out pretty much any information as far as metadata for you. If I click on here, you can see density, volume, mass, surface area, those are popular. If I click more, there's other choices I can do. Like if I wanted to see what manufacturers are listed, you can see if people have put in that custom property and it'll list what the property is. Another one under the more, and these are two great ones for when you're trying to maximize your assembly rebuild time or refresh time graphically. There's one that shows you graphic triangles. What that'll show you is that'll show you which parts are the most complex as far as how many triangles it has to draw. That's basically how SolidWorks creates a shape. If you look at a cube, it's just 12 triangles. It's pretty easy. But if you look at a cylinder, they've split the side face of that cylinder into triangles. That's what takes a long time to redraw. If you've got a lot of triangles, it's going to take longer to rotate the thing because it's got to redraw all those. So here I've got something that seems to be a pretty big culprit, and it's not even a big part. So there's balls in that ball bearing. We don't really need that much detail in the ball bearings. It's not going to really hurt me graphically when I'm looking at the entire assembly because the bearing's inside of the motor casing. But if I go to a wireframe or if I go to a hidden line shade, it's got to draw every one of those balls as I'm rotating it. And if I've got 15, 16 bearings in there, yeah, then I'm screwed as far as how this thing starts to react. This is from McMaster. They do put this thing in here, which kind of blocks it out, at least when you're doing shaded mode, but it still has the balls in there. If you wanted to get it, as lightweight as possible, you could just extrude a ring in there, overlap those as another configuration maybe. Probably would want to put a hole in that. But you get the idea, is that you can make one easier for you. There we go. And now that thing's not going to take any time to draw. Or I can still have the full version if I need to do it for renderings or whatever reason I want to see the balls inside the ball bearings. I could still have it there and then just use the configuration at the assembly level to make it run faster. Okay, I wanted to show you a couple of other things here to make life easier for you that are not basic SolidWorks tools. They're actually tools you have to look up for. Go to your programs, SolidWorks tools. The two that I'd like to talk about are Treehouse and Task Scheduler. So let me get into those. So what SolidWorks Treehouse is it's a way of either taking a look at the hierarchy of an existing assembly, or when you're creating an assembly, you can actually click and drag and drop parts and sub-assemblies and set up how you want your hierarchy, and it'll actually use your templates and create an assembly based on that. Or if you've got an existing assembly, like I do, oops, looks like I'm one level up. My assemblies. Here it is. If I drag and drop this from my File Explorer into the Treehouse, it'll show me the hierarchy of what's going on here, where the sub-assemblies are. So I need 4 of these. Oops. Inside of each of those, I need 2 of these, 2 of these. You can click on these things, see the custom properties inside of it as well. You can even put in custom properties from this level if you want to make sure all your metadata is there. But it's a good way of getting an overview of seeing what's going on. So you can use it to look at an existing plan. And like I said, you can actually add plans to it. If I wanted another subassembly, I could start fleshing that out, start naming those parts. It'll actually create it. Where it's going to drop it is origin on origin. It'll just drop it into that top level assembly as a subassembly in that origin, on the origin of the top level assembly. That one's kind of nice for getting a bird's eye view of what's going on. Another tool that is nice to use is this thing called Task Scheduler. Now we use this at Loon, at least in our vault. We've got some stuff that automatically starts the task scheduler, but it's pretty easy. If you wanted to, let's say, export a PDF file, you can go find a folder where all your drawings are, and say, okay, anything in that folder, I want you to make all drawings into PDFs. And it'll take a second. Didn't take much time at all. You can actually set the time that this happens over here where the date and time are. So you can have it happen after hours. You can have your computer make PDFs for you all night. But it'll open up SolidWorks and it'll just sit there and plug and chug, find every drawing for you, create a PDF. When you come in the next morning, all your stuff has been converted for you. It does actually open up a new SolidWorks thing to do this because it's got to use the license to actually do what you're asking it to do. All right. You can have another session of SolidWorks open while that one's running in the background. It does give you a warning to tell you that it doesn't really think that's a great idea. It just has to do with if you crash SolidWorks. you won't have much recourse of getting those files back if you've got 2 sessions running. But besides that, not much problems with it. Okay, I got 10 minutes left, and I'm going to tell you the thing that is the true wizard level of SolidWorks magic, and it's kind of understanding just a really basic concept of what a rebuild is and how SolidWorks takes a look at the geometry to get yourself more stable parts. So I'm going to start a part here, and I'm going to draw your attention to this choice verification on rebuild. Unfortunately, that is not on by default. I wish it was. It really should be. What it does is when you rebuild a part, it checks each feature that it's rebuilding for errors, and it'll flag you if it finds an error, if that's turned on. It adds a little bit to your rebuild time, but for your sanity of not pulling all your hair out because you had an error and didn't know about it, it's not going to save you that much time. This is a much better way to roll with that on. Let me show you why. I'm going to turn it off here, and I'm going to just start a sketch. Extrude it, mid plane. So you guys know how I'm using all these magic tricks right now, right? All right, put that one there. Start a sketch here. Quick Alt-C, circle, dimension. Okay. When SolidWorks does a rebuild, so if you look at a feature, bring up the dimensions here. If I change a dimension and just hit the green check mark, nothing happened. See how it's marked that feature with a rebuild? Same thing there. I've got a rebuild right here. When I hit this rebuild or Control B, it goes and takes a look at my feature manager tree and rebuilds anything that a change has happened to. You can do it in real time. Where when you do change the number, if you hit rebuild here, you can see it before you accept it. So you don't always have to wait on it, but that's typically what it does. SolidWorks saves up all these rebuilds, and we will rebuild them for you. Now you can put other features in here. You can reorder features, and take a look at when I do that. For a second, there's a stoplight on those things. It has to rebuild in order for it to figure out how this part looks. It has to say, okay, these 2 features have changed, but it does an automatic rebuild for you. Okay. The shell, I can move the shell to different locations. You'll see it has to rebuild to figure out the difference between those 2. Now, where the problem can happen is something like what I just did there. Let me make this fill a little bigger. And this shell a little thinner. All right, things are going fine. Here I've got a problem and I don't know it. See what's happening out the back of this thing? It shelled the box with a square end on it. And then I put that fillet in there, which is bigger than the size of the box. And it's letting me get away with this. If I was looking at it from this side, I would have no idea that there was a problem. I hit rebuild, nothing happens. There's nothing to rebuild. There's another trick, Control Q. So when you do Control B, it does a rebuild and looks for those stoplights and rebuilds everything. If I hit Control Q, it starts from the top and redoes everything. It's still not catching any problems. If I go to my evaluate and I do a body check, that'll tell me, hey, you've got a lot of problems here. This face, this face, this face, all this stuff's inconsistent. So if I ask nicely, I can see that there's an error, but unless I ask, I'm not going to know. Let's go back to the options. Performance. Turn that on. I want a verification on rebuild. Nothing happens because nothing's rebuilt, but I hit Control Q, pow, I get an error. Because now it's checking during the rebuild to see if anything fails. Where this catches a lot of people is when you upgrade SolidWorks, like when we went from 14 to 16, you bring all those files over, first time it opens in 16, it's got to rebuild it fresh, and it'll find errors that you never saw because you didn't have verification on rebuild on. And people are like, 16 sucks, it broke all my parts. No, actually your parts kind of sucked before, and you just didn't know it. So that's why it's a good idea to have that verification on rebuild so that when you do that Control Q, it'll actually flag you to say, hey, I found an issue here. Again, it saves you, microseconds per feature on every rebuild. So I guess over a year would save you like an hour or two. But like I said, it's not going to save you that hour or two of getting a call from somebody who's like, yeah, I can't run a code for this, or I can't do a 3D print. This feature, the thing's all jacked up. This is not a good part. Well, it seemed fine in SolidWorks and never told me. That's because you didn't have that performance thing. Please turn that on. And then you'll look like a true magician because your parts won't explode when you send them to people. All right. We've got a few minutes left here. Does anybody have any questions on anything we covered here today? This will be recorded, and so I will post the video here shortly for you. There's now 20 hours of these kinds of seminars out on our website. I'll include a link to that website. But this one was just more on how to get the best performance out of your SolidWorks on a day-to-day sort of feature-to-feature level. Hope you enjoyed it. And next month we'll be covering detailing and drawings.